There are many different ways to solve a quadratic equation, such as x squared plus 3x minus 10 equals 0. So far in the classroom, we have learned two different methods. The first method is factoring in zero product property. This requires us to use the generic rectangle and diamond problem and then set each of our factors equal to 0 and solve for x. The other method we learned in the more recent method is the quadratic formula. This is a little bit more extensive in work, but it works all the time for every single quadratic equation. Now we're going to learn a new method for solving quadratic equations called perfect squares. Perfect squares equations are best understood when you have something that is being squared equaled to a constant that is squared. To understand this better, let's take a look at an example. This example reads the quantity of 2x minus 1 squared equaling 25. Well, the something that we have squared is the 2x minus 5, and it is equal to a constant that was being squared. So to solve this, the first thing that we're going to want to do is get rid of the most outside operation. And in this example, it ends up being the squared. So to undo a squared is you're going to use the square root of both sides. Now what happens when you take the square root of both sides is the squared and the square root end up going away, leaving you with just the 2x minus 1. Now the thing that we have to be careful about is the square root of 25, that constant. When you take the square root of 25, you actually have two solutions. You have a positive solution, positive 5, and a negative solution, negative 5. This causes us to end up having two different equations, such as 2x minus 1 equals 5 and 2x minus 1 equals negative 5. This is very similar to when we solved using factoring and the zero product property. To continue solving, we're going to simply add 1 to both sides, leaving us with 2x equaling 6, and then simply dividing by 2 and giving us x to equal 3. Now we're going to do the same thing to the other equation. We're going to add 1 to both sides, get 2x equals negative 4, and divide by 2, giving us x to equal negative 2. Here are our two solutions. Now I'd like you to try this example on your own. This example, we have the squared, again, as our outermost operation, so we need to get rid of that first. To undo a squared, we're going to simply take the square root of both sides of the equations, because what you do to one side, you have to do to the other. Remember, when you take the square root of a squared, the squared and the square root end up canceling out, leaving you with just that x plus 4. The trick you have to remember, though, is when you take the square root of that constant, you end up with two solutions, the positive and also the negative. So we're going to set our x plus 4 equal to our positive 7 and our x plus 4 equal to our negative 7. Here we're going to solve for x by simply subtracting 4 from both sides and getting x to equal 3, or solving the second equation where you subtract 4 from both sides and x equaling negative 11. Here are our possible two solutions. Now, after seeing two perfect square equations, I would like you to try another one on your own. Here, the most outside operation, again, is the squared. And to get rid of the squared, you're simply going to take the square root of both sides. This causes the squared and the square root to cancel each other out, leaving you with just what's inside of the parentheses, your 3x minus 6. Now we're going to set this equal to the solution of the square root of 36. But remember, we have two solutions. The square root of 36 gives us both a positive 6 and a negative 6. So we're going to have 3x minus 6 equals positive 6. And we'll also have another equation, 3x minus 6 equals negative 6. We're going to go ahead and solve these just like we would with the zero product property, adding 6 to both sides and then dividing by 3. That's going to leave us with x equaling 4, or the other solution is when we add 6 to both sides. Here, we're going to get 3x to equal 0, divide by 3, and x equals 0. This will give us our two solutions to this perfect square equation. Solving perfect square equations can get even more complicated when you have extra operations in the equation. Let's take a look at an example. Here this example reads 3 times the quantity of x minus 7 squared plus 2 equaling 50. Now, in the very beginning, we talked about how you need to get rid of the most outside operations. Well, this is very similar to when you solve linear equations, where you would simply get rid of first your addition and subtraction. So here I have addition going on, and we're going to undo addition by simply subtracting 2 from both sides. And that's going to leave us with 3 times the quantity of x minus 7 squared equaling 48. Now the other most outside operation is that multiplication of 3. So to undo multiplying by 3, we're going to simply divide both sides by 3. That's going to make a giant 1 on the left side, leaving us with x minus 7 squared equaling 16. Now this is very similar to the first examples, where now all we are left with is the squared. To undo that squared, we're going to simply square root both sides. That squared and the square root are going to cancel each other out, leaving us with just simply x minus 7. But the solution to the square root of 16 is both positive 4 and negative 4. That's going to cause us to have two equations, x minus 7 equals 4 and x minus 7 equals negative 4. When we solve this, just like we would with the zero product property, we would add 7 to both sides, giving us x equals 11, and we would add 7 over here to both sides, giving us x equaling positive 3. Here are our two possible solutions.